Hello, this time I'm going to talk about a few questions on this particular exam. For those, hopefully it'll be also useful for A-level students in general. For those who don't know, A-level is the exam that students take when they're 18, and it also serves as a university entrance exam. If you want fully worked examples for the fully worked answers for these questions, you can go to that website there, maca.co.uk. They'll give you fully worked solutions for this particular exam, and also it'll give a link to the exam papers themselves. The exam papers themselves are copyrighted, but and sometimes if they're too recent they are barred, but otherwise they're freely available. So hopefully you can read this okay. I know you can freeze the frame here, so I don't need to hold it on the screen for too long. What can I say about this? I mean, the first part is just a straightforward diagram. So it's just something like this. I mean, even that's not a particularly brilliant sketch, but it shows the general ideas. You need to show that it's asymptotic here and crosses at the right point. You know, that's one, and so on. So general, that was okay. Now, the second part says solve for x equals 100. 4 to the power x equals 100. And this involves logs, and people always get logarithms always produces some kinds of problems with some students. So you have sort of like 4x equals 100. That's 4x. Solve that. So you'd say, okay, log 4x equals log 100. X log 4 equals log 100. So x equals log 100 over log 4. Right. I mean, that's very straightforward from there on. I mean, you can get most of you can probably guess what the major errors on this are. I mean, for example, x, log 100 over log 4 most certainly does not equal log 25. Nor does it equal log 100 minus log 4. You know, you always get a fairly decent section of students who try and want to put this type of thing down. Another thing to sort of note while we're on this is this is independent of what particular log you use. You can use any log for this and it'll get the same answer. I mean, if you want to satisfy yourself that that's true, you can use this particular formula, log using this formula you can move from this in terms of a particular logarithm and shift it into terms of another totally different logarithm altogether, just to show that this is the solution of this is independent of which particular logarithm you use. So this one, although it's fairly basic, this one was actually students typically lost quite a few points on this particular thing, basically because the layout and slightly sloppy way of presenting things. I mean, if you start off, you say dy by dx equals limit. Yeah, okay. So I'm using the small increment. I'm denoting the small increment here as delta x, and that would be for this particular point it would be 2x plus delta x squared.
Answering machine on. Advancement 1.
So first thing to notice here is that, well, the first thing to note here is that, you know, dy by dx has to be here, mentioned somewhere. A lot of people just left that out. And also this idea here, the limit, you know, if you just write this down, then you're going to lose marks. But then from then onwards, it's just really a straightforward arithmetic where nevertheless people did lose marks. I mean, you're going to end up with some like limit of dx equals 0, 4x plus 2 dot x. And lots of students, I mean, maybe as many as 50%, I can't remember, failed to achieve this. You know, they had sort of like plus delta x or something like that, some little fiddling little arithmetic error along the way, and you know, that's where most people tended to lose marks. Now this one here, this this first part, find the coordinates, x coordinates of p. I mean, most people did it correctly right up until the end and got the wrong answer. So I mean, it involves just differentiating this. You know, that was okay. So people would do that okay, but then eventually they would get the wrong value for x just on the last line. So I mean, what you've got cosine. You're going to end up with an equation like this: cosine x equals 3/4. Now, when dealing with trigonometrical functions, a lot of people just present the whole thing in quite a sloppy way, and well, ultimately they fail to. I'm talking about not obviously talking about everyone, but a sizable number of people just seem to fail to realise that a cosine would correspond to two values between 0 and 2 pi, and actually in reality it corresponds to a lot more than two values. And you can lay it down quite nicely in general, but for a cosine it's even better. You know, that's really, cosines are very nice to deal with when doing this type of problems, precisely because when you get rid of the cosine, you go half of x equals n 2 pi. In this case, I think it's plus or minus 0.7227. So that's the general solution when you're dealing with the cosine. It's nicely, just a nice little formula. And then the final step is to say x equals n 4 pi plus or minus 1.4454. But you can see what's happening here on the on this particular graph. You've actually got this p is actually the third maximum or minimum, or the third stationary point as you move rightwards from the vertical axis. And that's basically where a lot of people went wrong. I mean, I'm talking here basically about a really great majority. You know, most people just chose the first value. The number of people who got the right answer for this was, you know, very, very, very low. I can tell you that. So, I mean, yeah, I mean, that's... You're looking for the third stationary point, so you get the general formula. So you start off with 0, 4 pi plus or minus. Well, I mean, the minus, you know, we're just dealing with positive values here, so we can just forget about the forget about the negative value here. So you get the n equals 0 gives you the first value, the first stationary point. Then go right round to n equals 1, so that's 4 pi plus or minus that. So 4 pi minus that will give you the second stationary point, and then finally the 4 pi plus that will give you the x coordinate of p, which I think is 14, which which, as I say, very few students actually got that correct. Now this one here, I would recommend that when you've got a sort of seemingly complicated integral like this, that you first off see whether you can play around with the integral using a bit of arithmetic to see if you can get it into a simpler form. I mean, a lot of people, well, you know, quite a markedly high number of people tried to do integration by parts or substitution. That's not really necessary to my view. If you start off with the integral as the integral of x plus 2, x minus 2 I should say, x minus 4 over 4, then that is equal to that's gives you a bit of a clue what where we're going. So that's x 3 over 2 minus 6x and a half. Right, so that's what my suggestion. You've got now three separate integrals which are fairly straightforward. It was surprising here that actually, although most people did actually try and go in this direction, of those people who went in this direction, a sizable proportion managed to get these coefficients wrong, which, as far as I can make out, is through actually multiplying by 4 rather than dividing by 4. But I mean, you know, it's a silly mistake. But in essence, they lost half of the marks by doing this. You know, there were 6 marks for this particular example, I think. Three method marks and 3 accuracy marks. And if you got the coefficients wrong, then you'd automatically lose half your marks just for that mistake. Oh yeah, you can previously work out the limits, which are this here. Now, one thing to note, obviously, is that if you just integrate, as I've just done here, what you will actually get out will be the negative of this area. So that's quite important to point out. And to my mind, the best way to do that is just to do the straightforward integral, and then take the negative of the final answer that you get out. I mean, some people were playing around with taking the negatives of the initial values right at the beginning, which is mathematically correct, but I would recommend, you know, not actually doing that, just doing it as in the manner that I've just stated. Right, part A was done. Most people got the right answer here. They would take the inverse value, the inverse function of that particular function, and then just insert 3 over 2. But an alternative way of doing this, something for you to think about, is to say, okay, 8x plus 5. That's the original function, and then that equal to 3 over 2. That would be a more direct way of doing it, something for you to think about. And I think the answer came out as x equals minus 1 over 10. The ranges caused a bit more. I mean, B was fairly straightforward. You know, it's a fairly straightforward question, but a lot of people tend to make a bit of a mess of that. For some reason, it really involves long division, and you can almost do it in your head, really. C asks you to state the range of g to the minus 1. Well, if the domain is if the domain of g is as given here, then the range of g to the minus 1 will be the same across the same values. So the range of g to the minus 1 is 0, x is greater or equal to 0, less or equal to 4. And then it says find the range of f g to the minus 1. Well, there's a couple of ways of doing this. You're trying to find the range of that particular function. Now what you could do is, if I can state this briefly, what you could do is you could take the range of g to the minus 1 and just test it. Take the one extreme value of the ranges and substitute it for x. For example, one of the extreme ranges is 4, isn't it? So that will be that will give you 8 over 4 plus 5. And then you can take the other extreme of the range, which is 0, stick that in, and that will give you 5 over 3. 8, 0. An alternative way some people did was to work out g minus 1 explicitly, which is and go from there, stick this into here. Now the important thing here is that not to let x equal range between 0 and 4. Again, this is quite needs a bit of thought really, but what this x is different from this x here, as it's just done now. In the previous example I treated this x as or the possible values of x, the extreme values of x corresponding to the extreme values of the range of g to the minus 1. But if I substitute that into here, then this is a different x completely. And this x relates to the domain of g to the minus 1. And you find that the domain will be between 0 and 16. So those are the values of x that you'll need to stick into here, if that's the method you want to use. Again, I don't want to go on about it. It's just something you need to think about if it doesn't chime exactly straight away. One thing I could say while I'm on this is that when they ask for the range, the range of g to the minus 1, as I've just said, it goes between 4 and 0. So that's your answer to part C. The important point is that the middle bit is g to the minus 1. It's asking for the range of g to the minus 1, so that's the way you present it. You most certainly do not put down x, which will be wrong straight away. Some people put down y, which would get the mark in this particular case, because you're talking about, you're generally talking about the range. The range relates to the values on the vertical axis. So you stick down y, you've got the right idea. And for this particular example, you would have got the mark. But the fully correct thing is to write down g to the minus 1 when you're talking about the range of g to the minus 1. So again, this started out quite well. Part A, quotient rule, and so on. I mean, the major error that crops up here is a small number of people confuse the quotient rule with the product rule. I mean, you could use the product. Well, this might be confusing to say this, but you could use the product rule here if you're taking one of the values to be 4x squared plus k all to the power of minus 1. You could use the product rule there, but in general, this is where you would use the quotient rule. Now, part B says, given that the curve has at least one stationary point, find the range of possible values of k. Now, G. I'm trying to find out what G was now. I'm fairly certain that G was some sort of produced a rational function here. So if you're finding the stationary point, what you really needed to do, well, take it from me that what you really need to do is to solve that equation there. 12x squared minus 8x plus 3k. When you've got a rational function as the derivative, you only need to look at the numerator, or you only need to set the numerator equal to 0 and go from there. But when it says, given the curve has at least one stationary point, find the range of possible values of k, then what you need to stick down is, at the beginning is p squared equals, that's the condition that you need to meet. These are A, B's and C's in the quadratic formula. So you're setting that quadratic formula equal to 0, and in order for that to have that quadratic equation to have at least one stationary solution, real stationary solution, these conditions have to be met, or this condition has to be met. And really, once you've done that, then it's pretty straightforward. What you get out in a straightforward method would be something like this. And that would get the right answer. That would get the full marks. Although technically speaking, if you look back, it says up here where k is a positive constant. So actually, that would be the full solution to be honest. But if you put down that, you would have still got full marks in this particular situation, or for this particular question. I think the one thing to state here is that it helps if you write these vector equations and so on down in a fairly well laid out manner. Otherwise it can get very confusing. Now the first part relies on the fact that A, B and C lie on a straight line. So essentially you've got to sort of, you can work out those A, B, C. So essentially you've got the vectors that represent A, B and C are just vectors formed from these values from here. I mean, these obviously are vectors anyway, but aren't they? But what I'm saying is that if you're writing down A, B, that would be the vector from there to there. Then that would be -4, 7, 1. So to my mind, it's going to be much more simpler if you write the vectors down in this form rather than that form. So what I need to, sorry, I'm getting a bit off track here, but these are on a straight line. So I need to work out what A to B or B to C, or I could have A to C, and then use the fact that they are on a straight line, i.e. they are multiples of each other. So AB is that, BC is that, -16, P minus 4 over 4. Right, so as I say, you could also get AC, but I only really need two two vectors here. And what I just do is, I just realise now that because these are a straight line, AB equals lambda. Okay, so do I need to specifically write this down? You've got 471 equals lambda. And that'll give you three independent equations. Well, three equations if these are independent. So, for example, you're saying that 4 equals lambda minus 16. So that will tell you that lambda is... oh, sorry, that's minus 4, isn't it? That'll tell you that minus 4 equals lambda times minus 16. So that'll tell you that lambda is 4. And then the second line will tell you that 7 equals lambda. And therefore you can use that to find out what P is, which I think is 32. This part B is can get a bit complicated. So this is really where it helps if you lay things out properly and you actually state what you're doing. The reason I say that is not just that it's inherently can get a bit difficult, but there's a couple of ways of doing this. So if you don't say what you're doing, you can get very, very opaque, and these markers marking 100 or so these answer sheets can get a bit boring after a while. So, but essentially, what are we told here? We're told that. Well, we're told that OD equals that's what we're told in the question. OD is some multiple of OB because OB has been extended further along on its path. So therefore, that would equal lambda OB. I'm sorry if I stuck down that correctly. Oh yeah. Now what I also can deduce from that, I can work out CD. CD is equal to OD minus OC. CD is mentioned in the question as being parallel to OA, so it'll be helpful if I can work out what CD is. So I know what OD is from here, and CD is given by this. Which equals from above okay, so that's just OC is just from here, using the value of P that I've worked out. Therefore equal to 0.046. Now that's CD. CD is also, as given in the question, it's also parallel to OA. So that's that stated in a mathematical form. CD is parallel to OA. And again, I know what OA is from up here. So I can extend that to a full-blown equation if I can fit it on. Okay, so that's CD, that's from there, equals lambda OA, which is 4 minus 3, 5. So by analogy with what I've said before, I've now got actually 3 equations which hopefully are independent. Well, they are independent. So three equations, I've got 2 unknowns. That's enough to find out what those 2 unknowns are. For example, from the top line, minus 16 equals mu 4, so mu equals minus 4. Again, I think have I done that incorrectly or not? 4 and 16. Sorry, yeah, it's minus 16, isn't it? So it's actually mu equals plus 4. And lambda, as it turns out, is 5. I'll leave that to you yourself if you want to work it out. So therefore OD, sticking it back into the original right at the top there, OD equals that. So therefore OD equals 5, lambda equals 5, 0, 4, 6, which equals 0, 20, 30. Right. Again, the question asks, find that. Now, a lot of people seem to just start. Sorry, I should stop saying a lot of people. A small number of people, but a marked number of people just stopped there, under the idea that was what was being asked. But that says find the magnitude of OD. So you need to use, to find the magnitude of this, i.e. the magnitude of this, you need to use Pythagoras. So it becomes the square root of 0 squared plus 20 squared plus 30 squared. And that will come out to 10 times the square root of 13. The final one I want to talk about is this this one. Now you've been told that these sequences are in geometric series, and the standard way of handling this is to realise that when you've got 3 terms in a geometric series, then you can form ratios. The ratio of the second to the first equals the ratio of the third to the second. So here it'll be 5 plus 2 sine theta over 12 cosine theta equals 6 tan theta over 5 plus 2 sine theta. Okay, so that's the rule that needs to be stressed, and once you're happy with that, that'll make things a lot easier for you in questions like this. So you solve that to find out this particular function, this particular quadratic. It then says, given that theta is an obtuse angle measured in radians, solve the equation to find the exact value of theta. Now this harks back to what I was saying right at the beginning, that some people don't seem to realise it's when you're working out with sines or cosines or tangents, then that particular value of sine, cosine or tangent will correspond to two two angles will be between 0 and 2 theta. And that's what happened here. A lot of people just took the principal value here of this sine, i.e. a value in the first quadrant. Well, the question does say quite specifically obtuse angle. So you're looking for the value in the second quadrant. When you then went on to find the final solution, which was to show to the sum of infinity in this form, if you got the wrong angle for part B, then that would produce problems for C as well. So I mean, anyway, the sum to infinity is the general sum to infinity is this, isn't it? 1 minus r. Now, you can sum things to infinity if r is less than 1, or its modulus is less than 1. Because if the modulus is less than 1 and the n becomes infinity, then that expression disappears. So, sorry, this just should be in general terms. But if it's s for an infinity, it becomes a 1 minus r. So you can then use the values you've given or worked out. So a, which is the first value, which is just 12 cos theta. So that's 12 cos theta over 1 minus r, which is one of the values, one of the ratios that you calculated, which could be 5 plus 2 sine theta over 12 cos theta. Right. So you can see what I'm saying, that if you get the wrong angle in part B, that this is going to affect your answer to this. Right, so just finish off. The one thing I could say about this is that okay, you work through that and you typically get something like minus 18 over root 3 plus 1 or similar. Now the question says find it in this form. Okay, 1 minus root 3, where k is a constant to be found. Now the actual answer here is 9 1 minus root 3. What actually happened is a considerable number of people, a very large proportion, just went from expression like this to expression like this. And if they did that, they lost 2 marks in this particular situation, because you need to show what you're doing. I mean, if you just go from there to there, there is always the possibility that you just sort of somehow guessed or something. At the very least, you have not shown to the examiner that you know what you're doing. So what you need to do is you need to multiply top and bottom by the complement. So for example, you could have minus 18 over root 3 plus 1. Multiply top and bottom by so you could have it the other way around, minus 1 plus square root of 3 if you want. But you need to do that and calculate that out to show that you know how to get this. Otherwise, as I say, you lost 2 marks in that particular case. Anyway, so thanks for, if you're still with me at this stage, thanks for sticking with me. And as I said, you can get full worked examples of these particular problems by going to the website I said at the beginning, which is www.maca.co.uk. And if you go to my YouTube channel, you'll get further videos on subjects which will hopefully be of use to you as well. So thanks again for sticking with me, and cheers for now.